Okay, we're going to continue with our organic chemistry. We're going to talk about alkanes today. Remember, alkanes are all single bonds. They have a general formula of CnH2n plus 2. Again, all single bonds. Another name for this series is called the paraffin series. Oops, a little gap there. It's called the paraffin series. They do not react readily. Okay, do not react readily. Again, typically unaffected by many reagents. And paraffin wax is a mixture of compounds from this series, which is another reason why they like to call it the paraffin series. Now, under normal conditions, the first four in this series are gases. Okay, they're small, they have weak intermolecular forces, and that's why they become gases. Your next 12 tend to be liquids, so as they start getting larger, their attractive forces become a little more stronger. And then, of course, the higher you go after this, they tend to be solids. But keep in mind, these solids will have low melting points. If you think back to inorganic chemistry, our intermolecular forces were hydrogen bonding, that being the strongest, followed by dipole interactions, followed by dispersion forces. You don't get a whole lot of dipole interaction here unless you have a special group on your alkane. That's why we tend to see more gases and liquids. We don't get a lot of strong intermolecular forces. Most of them tend to be dispersion forces. And then your dispersion forces are a lot stronger because as they get bigger, you have more electrons. And remember, dispersion forces were caused by the movement of electrons. Your straight chain alkanes always use a suffix when you're naming them, and that's ane, A-N-E. So you'll always be able to recognize that. And then for all of our alkanes, alkynes, alkenes, we have a special naming for the number of carbons. So if you were to have one carbon, you would use the prefix meth. 2 is F. 3 is prop. 4 is bute. 5 is pent. 6 is hex. 7 is hept. 8 is oct. 9 is non. And 10 is dec. So if we are talking about just our alkanes with the suffix ane, we'd have one carbon, and again, using your general formula, you would have 4 hydrogens. So this would be called methane. If you have C2, you're going to have H6, and then this would be ethane. If you have C3, again, 3 times 2 is 6, plus 2 is 8, so C3H8, you have propane, etc. Okay, so it keeps on going. Okay, you're not going to need anything above 10 because of the actual naming system, which we will get to in the next recording. All right, so from here, you can have a straight chain, but we can also have what we call branches. Some of those branches are called alkyl groups. Now, an alkyl group is actually, has the general formula CnH2n plus 1. So it's it could be an alkane, an alkyne, an alkene that is being branched off of your main straight chain. So when you have a hydrocarbon that is branching off of a straight chain, it's called an alkyl group. Now, if you have an alkyl group, they're going to replace the name. So it will replace ANE with YL. So if you had one carbon, it's going to have this formula. So if one carbon, you're going to have CH3. So instead of being called methane, this would be called a methyl group. Okay. So that's your methyl group. Your if it had two carbons branching off, 4, 5, CH5, you would have ethyl, the ethyl group, etc. So again, that's if you have a hydrocarbon branching off of a straight chain. Next, we need to talk about alkane isomers. I believe we talked about isomers earlier, but we'll focus just on the alkane isomers for now. So alkane isomers. Your first three are too small to have isomers. Now remember, an isomer is when you can have more than one arrangement with the same number of atoms. Or same molecular formula. Remember, your arrangement, they're going to call a structural formula. So the first time you see one is with butane. First possible is butane. And we did see that in the last one. We had butane and we had isobutane. Now, so butane only has the two, but as you get more carbons, you can have more isomers. For example, pentane has 3 isomers, hexane has 5, heptane has 9, octane has 18. You don't have to memorize how many they have. You will just have to be able to draw the different possible isomers. So we've already seen butane, so let's take a look at pentane. All right, so remember pentane, pent is 5, so you're going to have C5H12. Obviously, the very first one that you would always draw would be your straight chain. So you'd have carbon 2, 3, 4, 5. And don't forget, you have to have 4 bonds on every carbon. So what's left is going to be all single bonded hydrogen. So again, pentane, these all have to be single because it's an ane. And you can fill in your H's. So that's one possible structure. From there, if you're going to draw isomers, the next thing to do is start with a smaller chain. So our original chain is 5, so then you start with a 4. 1, 2, 3, 4. And then you branch another C. So you would end up getting an alkyl group, in this case a methyl. So you could have a carbon off of this one. Now keep in mind, if I were to draw it like this and put it here, those are the same. So this is not another isomer because it's the same as the other one. Not another isomer. They are the same. You just flipped it over. Okay? So it's not the same. And then you can put in your hydrogens. Okay, so there's one. Here's another. Then we can go down and you go to your, since this is the same, you go to your next chain. Sometimes people will draw structures like this. They'll go 1, 2, 3, 4, and then they'll put it here. Well, that's still a straight chain. So that's still the same as this one up here. Okay, just because you bent it a little bit doesn't make it a different structure. Okay, so keep that in mind. So we've got one with 5, one with 4. Next, we're going to look at one with 3. 1, 2, 3. I still have 2 carbons. where can they go? Well, they can't go on the end because we just saw all you did was bend it if you put it on the end. So you'd have to have one here, and you'd have to have one here. And then put in your carbons, and again, if you count, there's 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. C5H12. So these are all different structures. Different structural formula, same molecular formula. Those are isomers. Again, just watch as we start to learn how to name them. You will be able to see the difference. You'll be able to tell that this isn't really different than this if you are following the naming rules. So if we go through how do you know they're different, I'm going to just do a real quick one, and then we'll go through the rules in our next recording. But this is actually the one that is called pentane because you have 5 in a row. Okay. This one is no longer called pentane. This one, our straight chain is 4. So remember, 4 is bute. Okay, so this is butane, but it's butane that has CH3 coming off of it. Remember, CH3 that came from methane with one less hydrogen, so it became methyl. So this one is called methylbutane. Methylbutane. And then down here we have 3, so that's propane. And we have a branch coming off, one there and one here. That's a methyl group, so we do call it methyl, but we do have to let people know that there are 2 methyls. So this is called dimethylpropane. So our next recording, again, we'll go through all the rules for naming.